You can start.
Okay, sir. Good morning, students. I am KRUTIKA SHETTY. I'll be dealing with physics. So in a week, I have 3 classes. That is Friday, Thursday, Friday, Saturday. I'll be teaching you physics here. So according to the schedule, we have today mechanical properties of solids. So now we class and start madana. First now mechanical properties of solids alli questions nodukinta munche adಕ್ಕೆ related some formulas ಮತ್ತೆ synopsis ಅನ್ನ discuss ಮಾಡೋಣ. Okay. So ನಾನೀಗ share ಮಾಡ್ತೀನಿ, ನೀವು just ನೋಡಿ. I hope the PPT is visible to you. Is it visible, students?
Yes, ma'am.
Yes, okay. So mechanical properties of solids alli ನಾವು ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಮೇನ್ ಆಗಿ elasticity ಬಗ್ಗೆ, plasticity ಬಗ್ಗೆ, perfectly elastic body, perfectly plastic body examples ಮತ್ತೆ stress, strain, the types of stress, the types of strain ಬಗ್ಗೆ discuss ಮಾಡ್ತೀವಿ. And here one main law we are discussing, that is called as Hooke's law, which is giving you the relation between the stress and the strain. So first ನಾವು synopsis ಅನ್ನ discuss ಮಾಡೋಣ. So just highlights points ಅನ್ನ ನೋಡೋಣ ಈಗ. ಇಲ್ಲಿ ನೋಡಿ, first intermolecular force ಅಂತ ಇದೆ. So what is intermolecular force here? Intermolecular force you have already studied in the chemistry also. We know that in case of a solid ಏನಾಗುತ್ತೆ together. So we have 3 types of matter, that is matter exists in 3 types, that is solid, liquid and the gases. So in case of solid, we have the molecules are tightly bound to each other, and in case of liquid, the molecules are little away from each other, and in case of gases, the molecules are far away from each other. So intermolecular force now illi based on the intermolecular forces now solid ಮತ್ತೆ liquid ಮತ್ತೆ gases ಅಲ್ಲಿ distinguish ಮಾಡಬಹುದು. So what are the difference here? In case of solids, the intermolecular forces will be stronger, and in case of liquids ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇರುತ್ತೆ solids ಗಿಂತ, and in case of gases it will be more less than the liquids here. So you can see here the intermolecular force in a solid, atoms and molecules are arranged in such a way that each molecule is acted upon by the forces due to the neighboring molecules. These forces are known as what? Intermolecular forces. So here in this lesson we have elasticity. So what do you mean by elasticity here? ನೀವೀಗ ರಬ್ಬರ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು ಅಥವಾ ಸ್ಪ್ರಿಂಗ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಇಲಾಸ್ಟಿಸಿಟಿ, ಇಫ್ ಯು ಸ್ಟ್ರೆಚ್ ಎನಿ ಮಟೀರಿಯಲ್, ಯಾವ್ದಾದ್ರು ಮಟೀರಿಯಲ್ ಅನ್ನ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ಯು ಲೀವ್ ದಟ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್, ನೀವು ಅದನ್ನ ಸ್ಟ್ರೆಚ್ ಮಾಡಿ ಆ ಫೋರ್ಸ್ ಅನ್ನ ಏನಾದ್ರು ಬಿಟ್ಬಿಟ್ರಿ ಅಂತಂದ್ರೆ, the body will regain, it will come back to its original shape and size. That is called as what? Elasticity. Okay, so here the change in length may occur, the change in the diameter may occur, the change in the area may occur. So there is a change in the dimension takes place when you apply the force on the body. Okay, the next, perfectly elastic body. In the nature, actually we don't have the perfectly elastic bodies. So closely elastic body anta helbodu ನಾವು, which will regain its shape 100%. 100% ಆಗಿ shape ಅನ್ನ regain ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ನಾವು perfectly elastic bodies ಅಂತ ಹೇಳ್ತೀವಿ. So the examples, nearly equal examples, we consider it as quartz, we take it as phosphorus, and we take bronze are the example of nearly perfectly elastic bodies. Same way ಇಲ್ಲಿ ನಮಗೆ plasticity ಅಂತ ಇದೆ. So what about this plasticity? Elasticity ದು opposite ನಾವು plasticity ಅಂತ ಹೇಳ್ತೀವಿ. So that is the inability of the material. So elasticity ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the body will regain its shape, and in case of inelasticity, that is plasticity, the body does not regain its shape, is called as what? Plasticity. Okay, so same way we have perfectly plastic bodies also, which is nearly equal to, that is perfectly plastic bodies. Next in this chapter we have about the stress. What do you mean by stress here? So stress andre nodi, that is the definition yav tara barutte, it is the ratio of internal force produced when the substance is deformed in the area A over which this force acts. So method stress equal to F divided by A anta baribodu illi. The SI unit ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಫೋರ್ಸ್ ಅನ್ನ ನಾವು ನ್ಯೂಟನ್ ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತೀವಿ, ಏರಿಯಾ ಅನ್ನ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ, therefore the unit will be Newton per meter square. This is SI unit. CGS unit ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, It is dyne per centimeter square. Okay, the dimension formula is given by m raised to 1, l raised to minus 2, raised to minus 2. Right? Then next we have the types of stress here. What are the types of stress? That is, normal stress is there. So what do you mean by normal stress? It is defined as the restoring force. So ಯಾವುದೇ stress ಇರಲಿ, so ಇಲ್ಲಿ ನಾವು ಮೇನ್ ಆಗಿ ಎರಡು ಟೈಪ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದೀವಿ, that is normal stress and tangential stress. ಯಾವುದೇ stress ಅದ್ರದ್ದು ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ, that is the stress is given by it is force by area. So if it is a normal stress, whatever the force acting on the body will be there, it will be perpendicular to the surface. So perpendicular agi force act ಆಗ್ತಾ ಇದ್ರೆ ಅದನ್ನ ನಾವು normal stress ಅಂತೀವಿ. And tangential stress anta andre, that is acting parallel to the surface. I hope you are understanding the difference between the tangential stress and the normal stress here. So mathematically ಎಲ್ಲ same ಬರುತ್ತೆ, that is F by A. The only difference ಏನಾಗುತ್ತೆ, in case of stress it is perpendicular force per unit area. In case of tangential stress it is parallel force per unit area. Okay, so then next we have strain concept. So strain. What do you mean by strain here? When you apply the force on any bodies, so stress ಅಂದ್ರೆ ಏನು, force per unit area ಗೆ ನಾವು stress ಅಂತ ಹೇಳ್ತೀವಿ. Strain ಅಂತಂದ್ರೆ ಏನು, ನೀವು force apply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, the change in the dimension occurs. That is ಏನಾದ್ರೂ changes ಆದ್ರೆ, for example when you apply force on the rubber band, you can consider ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅದ್ರ ಲೆಂತ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಡಯಾಮೀಟರ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಯಾವಾಗ ಲೆಂತ್ ಮತ್ತೆ ಡಯಾಮೀಟರ್ ರೇಸ್ ಎಲ್ಲ ಚೇಂಜ್ ಆದಾಗ ಆಟೋಮೆಟಿಕಲಿ ಏರಿಯಾ ಕೂಡ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್? ಸೊ ಹಿಯರ್ ವಾಟ್ ಎವರ್ ದ ಚೇಂಜಸ್ ಯು ಆರ್ ಅಬ್ಸರ್ವಿಂಗ್, ದಟ್ ಚೇಂಜಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಚೇಂಜ್ ಇನ್ ದ ಡೈಮೆನ್ಷನ್. ಸೊ ಡೈಮೆನ್ಷನ್ಸ್ ಚೇಂಜ್ ಅಂತ ಅಂದ್ರೆ ಅದು ರೇಡಿಯಸ್ ಆಗಿರ್ಬೋದು, ಲೆಂತ್ ಆಗಿರ್ಬೋದು, ಏರಿಯಾ ಆಗಿರ್ಬೋದು. ಸೊ ಯಾವುದೇ ರೀತಿ ಚೇಂಜ್ ಇನ್ ದ ಡೈಮೆನ್ಷನ್ ಆಗಿರ್ಬೋದು. So ಇದನ್ನ ನಾವು strain ಅಂತ ಹೇಳ್ತೀವಿ. So what is the strain? See here, it is defined as the ratio of change in the size or shape to the original size or the shape here. It is called as what? Strain. ಗೊತ್ತಾಯ್ತಾ? That is ಏನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ಏನು ಒರಿಜಿನಲ್ ವ್ಯಾಲ್ಯೂ ಇದೆ, ಅದ್ರದ್ದು ರೇಷಿಯೋ ತೆಗೆದಾಗ ನಮ್ಗೆ ಏನ್ ಸಿಗುತ್ತೆ, strain ಸಿಗುತ್ತೆ. And it has no dimensions, it is just a number. ಯಾಕೆ ಇದು ಏನು ಡೈಮೆನ್ಷನ್ ಮತ್ತೆ ಯೂನಿಟ್ ಇಲ್ಲ ಇಲ್ಲಿ, ಯಾಕಂದ್ರೆ ಸಪೋಸ್ ಇಫ್ ಯು ಆರ್ ಕನ್ಸಿಡರಿಂಗ್ ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಅಪಾನ್ ಲೆಂತ್ ಯೂನಿಟ್ ಏನಾಗುತ್ತೆ, ಮೀಟರ್ ಮತ್ತೆ ಮೀಟರ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಸೊ ಮೀಟರ್ ಮತ್ತೆ ಮೀಟರ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, the unit will get cancelled. Therefore strain is a dimensionless quantity also, strain is a unitless quantity also, right? So whatever the value you are getting, it is just a number here. So we have mainly three types of strain. Strain allu kuda ನಾವು ಮೂರು ಟೈಪ್ ಅನ್ನ ನೋಡ್ತಾ ಇದೀವಿ, that is based on the dimensions. So based on the dimension, if there is a change in the length, it is called as what? Longitudinal strain. Okay, so if the deforming force produces a change in length alone, the strain produced in the body is called as what? Longitudinal strain, or it is also called as tensile strain. So now ಇಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಬುಕ್ ಅನ್ನ ರೆಫರ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಬೇರೆ ಬೇರೆ ಟರ್ಮ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಮೇನ್ಲಿ ಲಾಂಗಿಟ್ಯೂಡಿನಲ್ ಸ್ಟ್ರೇನ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಇನ್ ಕೆಲವೊಂದು ಬುಕ್ಸ್ ಅಲ್ಲಿ ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೇನ್ ಅಂತ ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ ಇದನ್ನ. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಫಿಗರ್ ಹಿಯರ್, ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಒನ್. ಸೊ ಫಸ್ಟ್ ಫಿಗರ್ ಏನ್ ನೋಡ್ತಾ ಇದ್ದೀರಿ, ದಟ್ ಇಸ್ ಫಿಗರ್ ಎ. ಸೊ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಸಿ ಒನ್ ಟ್ಯೂಬ್, ಸೊ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ತರ ಕಾಣ್ತಾ ಇದೆ, ರೈಟ್? ಸೊ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ದ ಲೆಂತ್ ಆಸ್ ಎಲ್ ಹಿಯರ್. ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಫೋರ್ಸ್, ನೀವು ಇಲ್ಲಿ ನೋಡ್ಬೋದು ಫಿಗರ್ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಗ್ತಾ ಇದೆ, ದಟ್ ಈಸ್ ಆನ್ ಬೋತ್ ದ ಸೈಡ್ ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಫೋರ್ಸ್. ಹೌದಾ? ಸೊ ಈ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆದಾಗ ಇಲ್ಲಿ ಚೇಂಜ್ ಇನ್ ದ ಡೈಮೆನ್ಷನ್ ಆಗುತ್ತೆ, ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್. ಓಕೆ, ಸೊ ಲಾಂಗಿಟ್ಯೂಡಿನಲ್ ಸ್ಟ್ರೇನ್ ಫಾರ್ಮುಲಾ ಕೂಡ ಇದೆ, ದಟ್ ಇಸ್ change in length upon original length. Then the same way we have the volumetric strain ಅಥವಾ volume strain ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. So it is also called as bulk strain also. So as I told you, ಬೇರೆ ಬೇರೆ ಬುಕ್ಸ್ ಅಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಟರ್ಮ್ಸ್ ಅನ್ನ ನಾವು ನೋಡಬಹುದು. So if ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಎಲ್ಲದರಲ್ಲೂ ಕಾಮನ್ ಆಗಿ ಫೋರ್ಸ್ ಅಪ್ಲೈಡ್ ಆನ್ ದ ಬಾಡಿ ಬರುತ್ತೆ. ಏನ್ ಚೇಂಜಸ್ ಆಗ್ತಾ ಇದೆ, if it is change in the length, it is called as longitudinal strain. If it is a change in volume, or if it is change in the volume, it is called as volumetric strain, or it is also called as volume strain, or it is also called as bulk strain. ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ನೋಡಿ, that is change in length upon original length. Okay, so all are all are here unitless only. All are here unitless only. Why? Because whatever the ratio you are taking, the ratio are same. Therefore, it is a unitless as well as dimensionless quantities. Okay. Last one, the type of strain is that is shear strain. This shear strain is defined as it is the angle tilt caused in the body due to tangential stress expressed is called as what? Shear strain. So, in figure ide nodi, idanna nodi nimge artha agbodu illi nodi. So, figure B. So, figure B alli you are considering one cylinder of length L. Here you are applying the force. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ನೋಡಿ, slight change in the angle it is taking place. It is creating some angle, right? So whatever the displacement you are showing, that displacement is denoted as delta x. You can see the force acting on the body. Therefore, this is nothing but shear strain. I hope it is clear to you and it is audible clearly. So shear strain, it is mainly based on the angle. Yes. Then the last concept of this lesson is Hooke's law. So what is this Hooke's law? Hooke's law is nothing but it is giving you, now ಈಗ stress ಅನ್ನು ನೋಡಿದ್ವಿ, strain ಅನ್ನು ನೋಡಿದ್ವಿ. Stress to strain relation is given by Hooke's law. So ಏನಿದು Hooke's law? Hooke's law, he will give the relation between stress and strain. He will say that the stress is directly proportional to. So according to Hooke, the stress is directly proportional to strain. So what do you mean by directly proportional? Andre one value ಹೆಚ್ಚಾದ್ರೆ ಮತ್ತೊಂದು ಕೂಡ ಹೆಚ್ಚಾಗ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ. That is, if strain is increasing, the stress is increasing, the strain is also increasing here. Okay. So, but one condition ಇದೆ ಇಲ್ಲಿ, within the elastic limit ಅಂತ ಹೇಳ್ತಾರೆ. What is that within the elastic limit? ಈಗ ನೋಡಿ, ನೀವು ರಬ್ಬರ್ ಬ್ಯಾಂಡ್ ಅನ್ನ ತಗೊಂಡು if you go on stretching that. So first stretch ಮಾಡಿ ಬಿಡಿ force ಅನ್ನ, it will come back to original shape. Right. So again, ಎಷ್ಟು force apply ಮಾಡ್ತೀರಾ ಅಷ್ಟದು strain produce ಮಾಡುತ್ತೆ. So go on increasing the force on the body. ಒಂದು ಪಾಯಿಂಟ್ ಗೆ ಹೋದ ನಂತರ ನೀವು ಅದನ್ನ ಸ್ಟ್ರೆಸ್ ಮಾಡಿದ್ರುನು ಮತ್ಲಬ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರುನು ಅದಾದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಕಮ್ ಬ್ಯಾಕ್ ಟು ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಆಗಲ್ಲ. ಹೌದಾ? ಸೊ ದಟ್ ಇಸ್ ವಾಟ್ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್. ಪ್ರತಿಯೊಂದು ಬಾಡಿಗೂ ಒಂದು ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅನ್ನೋದಿರುತ್ತೆ. ಸೊ ಆ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅನ್ನೋದು ಮೀರಿದ್ರೆ, ದಟ್ ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಮೀರಿದ್ರೆ ಆ ಬಾಡಿ ಇಲಾಸ್ಟಿಸಿಟಿ ಪ್ರಾಪರ್ಟಿ ತೋರಿಸಲ್ಲ. ಅದನ್ನ ನಾವೇನಂತ ಅಂತೀವಿ, ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದಟ್ ಇಸ್ ಸ್ಟ್ರೆಸ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಸ್ಟ್ರೈನ್ and within the elastic limit this law is valid. The ratio is called as, ಇಲ್ಲಿ ನೋಡಿ, ಈ proportionality sign ತೆಗೆದು ನಾವು equal sign ಹಾಕಿದಾಗ we will take one constant and ಅದು constant ಅನ್ನ modulus of elasticity ಅಂತ ಹೇಳ್ತಾರೆ. So again it is just a pure number and it is a constant value. ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವ್ದಾದ್ರು ರಬ್ಬರ್ ತಗೊಂಡ್ರಿ ಅದ್ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ಅಲ್ಯೂಮಿನಿಯಂ ತಗೊಂಡ್ರಿ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಹೌದಾ? ಸೊ ದಿಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಇಲಾಸ್ಟಿಸಿಟಿ ಅಗೇನ್ ವಿ ವಿಲ್ ಡಿವೈಡ್ ಇಟ್ ಇಂಟು 3 types. ಸೊ ದ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಇಲಾಸ್ಟಿಸಿಟಿ we divide it into 3 types. ಯಾವ್ದ್ರ ಮೇಲೆ 3 types ಆಗತ್ತೆ ಹೇಳಿ? ನಾವೀಗ ಸ್ಟ್ರೇನ್ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, 3 types of strain ಅನ್ನ. ಹೌದಾ? ದಟ್ ಇಸ್ longitudinal strain, bulk strain and the shear strain. So based on all the 3 strains, the ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಇಲಾಸ್ಟಿಸಿಟಿ ಅನ್ನ ನಾವು 3 ಟೈಪ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ವಾಟ್ ಆರ್ ದ ಟೈಪ್ಸ್ ಆಫ್ ದಟ್ ಇಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಇಲಾಸ್ಟಿಸಿಟಿ. ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಅಂತ ಬರುತ್ತೆ. ಸೊ ವಾಟ್ ಇಸ್ ದಿಸ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್? ನೀವು ಯಾವುದೇ ಮಾಡ್ಯುಲಸ್ ತಗೊಂಡ್ರು ಅದು ದ ರೇಷಿಯೋ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಸ್ಟ್ರೇನ್ ಅನ್ನೇ. ಹೌದಾ? But what is the difference here? The stress is different and the strain is different here. So Young's modulus antandre, it is denoted by the letter Y. It is the ratio of, you can see here, the Young's modulus is the ratio of what? Longitudinal stress to the longitudinal strain. ನಾನು ನಿಮಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ, ಯಾವುದೇ ಸ್ಟ್ರೆಸ್ ಇದ್ರೂ ಕೂಡ ಅದು ಎದ್ರದ್ ರೇಷಿಯೋ ಆಗುತ್ತೆ, ಫೋರ್ಸ್ ಬೈ ಏರಿಯಾ ಅಂತ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಲಾಂಗಿಟ್ಯೂಡಿನಲ್ ಸ್ಟ್ರೇನ್ ಇರೋದ್ರಿಂದ ಅದೇನಾಗುತ್ತೆ, ಲೆಂತ್, ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಅಪಾನ್ ಒರಿಜಿನಲ್ ಲೆಂತ್. So change in length we denote it with the delta letter, delta L by L. Okay, ಈ ಫಾರ್ಮುಲಾ ನ ನೆನ್ಪಿಡಿ, ಬಿಕಾಸ್ ನಮಗೆ ನೆಕ್ಸ್ಟ್ ಈಗ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯೂಸ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ, here whatever the formula you are seeing, ಏನಿದೆ ಫಾರ್ಮುಲಾ, that is Young's modulus Y is equal to force by area upon change in length upon initial length. ಹೌದಾ? ಸೊ ಇದನ್ನ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಯಾವ ರೀತಿ ಬರೀಬಹುದು? F upon A, ಇದು ಡೆಲ್ಟಾ ಎಲ್ ಬೈ ಎಲ್ ಇದ್ದದನ್ನ ರೆಸಿಪ್ರೋಕಲ್ ಆಗಿ ತಗೋಬಹುದು, ಎಲ್ ಅಪಾನ್ ಡೆಲ್ಟಾ ಎಲ್ ಅಂತ ಬರಿಬಹುದು. ಹೌದಾ? ನಮ್ಗೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ನ್ಯೂಟನ್ಸ್ ಲಾ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಗೊತ್ತಿದೆ. ಏನ್ ಹೇಳಿ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನ್ ಬರುತ್ತೆ? ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ? F is equal to you can tell the answers in chat box. According to Newton's law, F is equal to it is ma. Yes, 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 yes. Very good, students. So here, whatever the force is there, the force is equal to ma. So illi now acceleration due to gravity, instead of a we can take it as what? Mg anta tagobodu aita. Illi mg into L upon a into delta L. So ಇಲ್ಲಿ ನೋಡಿ, ನೀವು ವೈರ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ the area of the wire is given by, so the formula is also written as mg into L upon, so area of the wire is given by pi r square into delta L. ಈ ಫಾರ್ಮುಲಾನ ನೆನ್ಪಿಡಿ. ನಮ್ಗೆ ಏನ್ ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ ಆ ಡಾಟಾ ಮೇಲೆ ನಾವು ಫಾರ್ಮುಲಾನ ಚೇಂಜ್ ಮಾಡಬಹುದು. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸೊ ಇಲ್ಲಿ ಫಸ್ಟ್ ನಾವು ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಅಂಡ್ ಸ್ಟ್ರೈನ್ ಬರೆದ್ವಿ. ಅದರ ನಂತರ ನಾವು ಇಲ್ಲಿ ರೀಅರೇಂಜ್ ಮಾಡಿದ್ವಿ ಫಾರ್ಮುಲಾನ. ಅದರ ನಂತರ F is equal to substitute ಮಾಡಿದ್ವಿ. Next A is equal to, for the wire we have substituted the value here. So based on the given data ನಾವು ನಮ್ಮ ಫಾರ್ಮುಲಾನ ಚೇಂಜ್ ಮಾಡಬಹುದು. ನೀವು ಇಲ್ಲಿ for the dimension formula and the unit you are able to see here. Okay, yes, so let us go for the next type of stress. That is bulk stress. So it is the ratio of, that is volumetric stress to the volumetric strain, or we can say that bulk stress to the bulk strain ratio is called as bulk modulus. It is denoted by the letter B. You can see the formula. F by A is bulk stress. Bulk strain is given by what? That is delta V by B. Change in volume to the initial volume. So ಇಲ್ಲಿ ನೋಡಿ, force by area ನಾವು pressure ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ, ಹೌದಾ? So force by area is also called as pressure. This volume we are writing it in the denominator. ಇಲ್ಲಿ ನೀವು ನೋಡಬಹುದು, ಈ ಫಾರ್ಮುಲಾ ಅಲ್ಲಿ ನಾವು ನೆಗೆಟಿವ್ ಸೈನ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಯಾಕೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದೆ ಅಂತಂದ್ರೆ, how the volume of that given container is decreasing with increase in the pressure. ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅಷ್ಟು ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಪ್ರೆಷರ್ ಅಂಡ್ ವಾಲ್ಯೂಮ್ ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು each other. Therefore here we have the negative sign. You can see ಇಲ್ಲಿ ಬರ್ದಿದೆ ಕೂಡ. ಇಲ್ಲಿ ಮತ್ತೊಂದು ಪಾಯಿಂಟ್ ಇದೆ ನೋಡಿ, whatever the reciprocal of this bulk stress is there or bulk modulus is there, it is called as compressibility. It is called as compressibility. Then the last type of modulus is shear modulus, or in some of the book we studied as modulus of rigidity. What it is the ratio of tangential stress to the shear strain. So you can see the formula. Tangential stress is given by force by area, shear strain is given by theta. Okay, so idu more type aitu, that is Young's modulus, bulk modulus, shear modulus. These are the three types of modulus of elasticity. Then one more point is Poisson's ratio. What is this Poisson's ratio? Poisson's ratio is nothing but it is the ratio of change in diameter to the original diameter. Aita? And it is called as what? Lateral strain. So illi change in diameter to ನಾವು ಇಷ್ಟರವರೆಗೆ ಲೆಂತ್ ಮತ್ತೆ ವಾಲ್ಯೂಮ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. So Poisson's ratio, it is a special case here. It is the ratio of what? Change in diameter to the original diameter ಅನ್ನ lateral strain ಅಂತ ಹೇಳ್ತಾರೆ, ಆಯ್ತಾ? Then the ratio of change in length to the original length ಅನ್ನ longitudinal strain. ಇದೆರಡರದ್ದು ನೀವು ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ ಯಾವ್ದೆರಡರದ್ದು, that is lateral strain to the longitudinal strain is called as what? Poisson's ratio. It is called as Poisson's ratio. Again, it is a unitless and the dimensionless quantity. Okay, I hope the synopsis part is clear to you. Just lastly, I am showing you the relation between stress and strain with graph. You can see here the stress strain curve. You can also see how the different points are there on the graph. First O ದಿಂದ A ವರೆಗೆ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ they are proportional to each other. ಯಾವುದು ಸ್ಟ್ರೆಸ್ ಮತ್ತೆ ಸ್ಟ್ರೈನ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಈಚ್ ಅದರ್ ಆಗುತ್ತೆ, ಹೌದಾ? ಅದಕ್ಕೆ ಇಲ್ಲಿ ನಾವು ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಅನ್ನ ನೋಡಬಹುದು. Then A to B also you can see this. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕರ್ವ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So A to B ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, it is valid Hooke's law, ಆದ್ರೆ 100% ಆಗಿ ವ್ಯಾಲಿಡ್ ಆಗಲ್ಲ. Okay, then next C point you can see that is A point is called as proportional limit. ಯಾಕೆ proportional limit? Because the Hooke's law is valid here. Then yield point ಅಂತ ಹೇಳ್ತೀವಿ, B ಗೆ ನಾವು yield point ಅಂತ ಹೇಳ್ತೀವಿ. Then C is called as permanent set. Then E is called as fracture point. So this is stress strain curve. ಇಲ್ಲಿ ನೋಡಿ, stress is along y axis, strain is along x axis. So ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಈ ಗ್ರಾಫ್ ಅನ್ನ ನೋಡಬಹುದು. ಅವರು ಇಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೈನ್ ಕರ್ವ್ ಕೊಟ್ಟಿ ಯಾವುದು ಅಂದ್ರೆ ಸ್ಟ್ರೆಸ್ ಯಾವ ಎಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇದೆ, ಸ್ಟ್ರೈನ್ ಯಾವ ಎಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇದೆ ಅನ್ನೋದನ್ನ ರಿಮೈಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸ್ಟ್ರೆಸ್ is along y axis and strain is along x axis. So this is regarding the synopsis part. Now let us go for the questions for the today's class. Yes, I hope the synopsis part is clear to you. If you have any query, you can ask. Or else we will go with the question answers. So I am sharing the PPT here. Okay, students, let us start with the question answers. Okay, so here we have the first question. Yes, so I hope you are sitting with a book so that you can copy down the solutions. A body of mass 1 kg is attached to one end of a wire and rotated in horizontal circle of meter 40 centimeter. So ಇಲ್ಲಿ ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, the body mass is given as 1 kg. So m is given and it is attached to the wire and rotated in a horizontal circle of diameter 40 centimeter with a constant speed of 2 meter per second. ಅಂದ್ರೆ speed value ಇದೆ, diameter ಇದೆ. What is the area of cross section of the wire if the stress developed in the wire is, it is 5 into 10 to the power of minus plus 6. Okay, idu 10 to the power of 6 ide. Okay, so this is 10 to the power of 6 Newton per meter square. So in the given data, mass is 1 kg. Mass is given as 1 kg. Then next, the stress is given as, stress antandre S is equal to, it is 5 into 10 to the power of 6 Newton per meter square. Matte ಏನು ಹೇಳಿದ್ದಾರೆ ಅವರು, that is speed is given as what, 2 meter per second, right? Then next, so diameter is given as how much it is, 40 centimeter. The diameter is given as 40 centimeter. So it is actually the radius here, it is not a diameter. So the radius is 40 centimeter. Centimeter ಅನ್ನ ನಾವು ಇಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ ಮೀಟರ್ ಅಲ್ಲಿ. That is 40 into 10 to the power of minus 2 meter, right? So 40 into 10 to the power of minus 2 meter. Yes. So here Prakruti is giving answer, it is option C. So we are just using the formula and simplifying this. We know that simple agide, stress is equal to formula use ಮಾಡಿ ನಮ್ಗೆ ಏನು ಗೊತ್ತಿದೆ, stress ಅಂತ ಅಂದ್ರೆ it is force by area. ಹೌದಾ? So area ಕೇಳ್ತಾ ಇದ್ದಾರೆ, therefore area is equal to force upon stress. So force ಕೊಟ್ಟಿಲ್ಲ, force ಹೇಳಿದ್ದಾರೆ, mass ಕೊಟ್ಟಿದ್ದಾರೆ, speed is the radius. ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಿದೆ ಅಂದ್ರೆ ಸರ್ಕಲ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ಹಾರಿಜಾಂಟಲ್ ಸರ್ಕಲ್ ಅಲ್ಲಿ ದ ಬಾಡಿ ಇಸ್ ಮೂವಿಂಗ್. ಸೊ ಯಾವಾಗ ನಾವು ಸರ್ಕಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಬರುತ್ತೆ ಇಲ್ಲಿ. ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ಅ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್, ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಾಟ್ ಇಟ್ ಇಸ್ mv² upon r divided by stress. ಹೌದಾ? ಸೊ ಈ ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಏರಿಯಾ ಬರುತ್ತೆ. ನೀವು ನೋಡಿ, ಮಾಸ್ ಅನ್ನ 1 kg ಅಂತ ತಗೊಳ್ಳಿ, ಸ್ಪೀಡ್ ಇದ್ದು 2 meter per second ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ mv². ಸೊ 2 square 4 ಆಗುತ್ತೆ, ಆಯ್ತಾ, ಡಿವೈಡೆಡ್ ಬೈ. ದೆನ್ next we have r. So r is 40 into 10⁻². Next stress value substitute ಮಾಡಿ. So this is diameter ಅಂದ್ರೆ ರೇಡಿಯಸ್ ತಗೋಬೇಕಂದ್ರೆ ನೀವು ಇಲ್ಲಿ ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, ಅಂದ್ರೆ 20 ಅಂತ ತಗೊಳ್ಳಿ ಅದನ್ನ. Okay, so 20 into 10⁻², that is nothing but 0.2. ಹೌದಾ? So ಇದು 20 ಆಗ್ಬೇಕು ಇಲ್ಲಿ, it is not 40, it is 20. So 20 into 10⁻² into nimdu stress value. So if you substitute mass as 1 kg, v² as 4 and radius as 20 into 10⁻², then stress value is 5 into 10⁻⁶. So if you simplify the values, you will get the answer as, ನೀವು simplify ಮಾಡಿ, ನಾನು ಇಲ್ಲಿ substitution ಹೇಳ್ತಾ ಇದ್ದೀನಿ. That is 4 millimeter square. Option C is right one here. Option C is the right one. Solution ಅರ್ಥ ಆಯ್ತಾ? ಯಾರಿಗಾದ್ರೂ ರಿಪೀಟ್ ಮಾಡ್ಬೇಕಾ? ಸೊಲ್ಯೂಷನ್ ಅರ್ಥ ಆಯ್ತಾ ನಿಮ್ಗೆ ಇದು? So we know stress is equal to force by area. So force ನಮ್ಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಟ್ಟಿಲ್ಲ ಅವರು, ಬಾಡಿ ಸರ್ಕಲ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದಾರೆ. So it is a centripetal force is given by mv² by r upon stress. Area is equal to. So all the values are given, just substitute, calculate, you will get it as option C. So if it is clear to you, I'll go for the next question. Okay, then the next question is, in a wire, when elongation is 2 centimeter. So in a wire, the elongation is given as what? 2 centimeter. Energy stored is E. If it is stretched by 10 centimeter, then the energy stored will be. So here elongation ಕೊಡ್ತಾ ಇದ್ದಾರೆ. Elongation ಅಂತಂದ್ರೆ ಇದು change in the length ಅಂತ ಆಗುತ್ತೆ. Okay. So here energy stored they are asking. How we can do this one? Here it is given as, here we can write it as, see this, the energy is equal to, it is half kx², it is half kx², aita. So this is energy is equal to. Now it is when the elongation is 2 centimeter. Now they are saying that the elongation is 10 centimeter. So for that I'll write E dash is equal to, I'll take it as 1 by x dash square. This is kx dash square. Equation 1, equation 2, right? So now we can take the ratio of these two. So either the ratio ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ, half k cancel ಆಗುತ್ತೆ, ಹೌದಾ? We are getting only in terms of x and x dash. So you can take the ratio and you can simplify. ನೀವು try ಮಾಡ್ಬೋದು ಅಥವಾ ನಾನು ಇಲ್ಲಿ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ. So here it is E divided by E dash is equal to x divided by x dash whole square. ಸೊ ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಸೊ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ 2. ಇಲ್ಲಿ ಕನ್ವರ್ಷನ್ ಏನ್ ಅಗತ್ಯ ಇಲ್ಲ, ಅವ್ರೇನು 2 ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ನೀವು ಕನ್ವರ್ಷನ್ ಮಾಡಿದ್ರು ಕೂಡ ಇದಾಗತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ 10⁻². Okay, so divided by 10 here. Yes, so this is whole square. Simplify. What is your E dash is equal to? ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ ಆನ್ಸರ್ ಇದಕ್ಕೆ? Therefore, E is equal to, yes, option D, yes, yes, very good. Okay, students, correct. I hope the step is clear to you. Let us proceed to the next question. Then the next question is, so question number 3, 2 wires A and B are of the same length. So ನೋಡ್ತಾ ಹೋಗಿ ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ಸೇಮ್ ಲೆಂತ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. The diameters are in the ratio of 1:2 and the Young's modulus is in the ratio of 2:1 if it is pulled by the same force F. So force same ಇದೆ, ಮತ್ತೆ ಏನ್ ಸೇಮ್ ಇದೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು, ಲೆಂತ್ ಕೂಡ ಸೇಮ್ ಇದೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Then their elongations will be in the ratio of, so here the some students are giving the option that is 2.1. Harshita is telling it as 2.1. Yes. How to do this? So again, that is right, it is 2.1. Option D correct agide. So solution nodana. Okay, so here the ratio of the diameters are given as what? That is, I'll take it as D1:D2 is equal to, it is 1:2. The ratio is 1:2. Then the modulus, Young's modulus is in the ratio of, it is y1:y2 is equal to, this is 2:1. ಹೌದಾ? Then the length same ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಮತ್ಲಬ್ original length is same ಅಂತ ಇದೆ, ಮತ್ತೆ ಏನದೆ force ಕೂಡ same ಅಂತ ಇದೆ. ಹೌದಾ? So whatever your Young's modulus is equal to expression is there, ನಮ್ದೇನದು expression ಇದೆ, that is, ಆವಾಗ ನಾನು ನಿಮಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ತೋರಿಸ್ತೆ, it is initial length ನಾನು L ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ, change in length I'll take it as delta L. It is stress upon strain. After simplifying we are getting this equation. So we need to take the ratio of these two. ಹೌದಾ? ನಮಗೆ delta L by L ಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, that is, if they are pulled by the same force then their elongation will be, right? So you can take the ratio of both the delta L's, force is same, Young's modulus ratio ಮತ್ತೆ diameter ratio ಅಷ್ಟೇ ಕನ್ಸಿಡರ್ ಮಾಡಿ ನಾವು ಇಲ್ಲಿ ಮಾಡಬೇಕಾಗುತ್ತೆ. Okay, so if you consider for A object, this is the expression FL upon A into delta L, and for YB it will be FL upon A into delta L B ಅಂತ ಆಗುತ್ತೆ. So ನಾನು ನಿಮಗೆ ತೋರಿಸ್ತೀನಿ ಇಲ್ಲಿ, that is YA upon YB is equal to, it is YA upon YB is equal to F into L upon A ಅನ್ನ ನಾನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, it is pi r square because it is a wire. Okay, delta L into, this is for A, therefore I'll write it as A. Then for second one it is pi r2 square upon, sorry, delta LB upon F into L. ಇಲ್ಲಿ R1 ಅಂತ ತಗೊಳ್ಳೋಣ. ನೋಡಿ, ಸೇಮ್ ಫೋರ್ಸ್ ಅಂತ ಅಂದಾಗ ಇದು ಫೋರ್ಸ್ ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಕೂಡ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಇದು ಕೂಡ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಈ ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ಇದು ಪೂರಾ ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. Pi is a constant, that will also get cancelled here. So you are left with only your radius and the change in the length value, that is given by, this is equal to, so that is nothing but R2 square into delta LB upon R1 square into delta LA. ಹೌದಾ? So YA by YB ratio, YA by YB ratio ಏನಂತ ಇದೆ, y1:2, this one is how much, it is 2/1, it is 2/1, which is equal to, so your radius, ಅವರು ಡಯಾಮೀಟರ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಹೌದಾ? ಡಯಾಮೀಟರ್ ಅನ್ನ ಕೊಟ್ಟಾಗ ಡಯಾಮೀಟರ್ ಯಾವ ರೇಷಿಯೋದಲ್ಲಿ ಇದೆ, 1:2 ಅಂತ ಇದೆ, so it is 2/1 ಅಂತ ಆಗುತ್ತೆ, 2 ಸ್ಕ್ವೇರ್ ಅದು 4 ಅಂತ ಆಗುತ್ತೆ. right? So here you have delta LB upon delta LA. So LB by LA 2/4 ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? 2/4 ಅಂದ್ರೆ ಇದು 1/2 ಅಂತ ಆಯ್ತು. 1/2 ಅಂತ ಆಯ್ತು. ಅದ್ರಲ್ಲಿ LB by LA ಇದೆ, ನಮ್ಗೆ LA by LB ಬೇಕು. therefore whatever answer you are getting, it's reciprocal we are taking. So 2:1. LB by LA 1:2 ಆಗತ್ತೆ, LA by LB 2:1 ಆಗತ್ತೆ. therefore option D is the correct answer here. Okay, I hope you have taken down the solution. So please take down the solution along with me. Because of the lack of time, we can't wait for a longer time. You take the solutions along with me only. Let us go for the next question. Hooke's law essentially defines, so it is based on the theory point here. Hooke's law essentially defines, that is stress, strain, yield point, elastic limit. Can anyone tell me? A, B, C, D. Yes, Sagar, Lohit. Yes, it is option D. It is elastic limit. Yes, very good. So it is option D. Harshita, yes, right. Okay, then the next question. Longitudinal strain is possible in case of. So longitudinal strain is possible in case of. Longitudinal strain ಅಂದ್ರೆ ಎದಕ್ಕೆ ರಿಲೇಟ್ ಆಗುತ್ತೆ? ಲೆಂತ್ ಗೆ ರಿಲೇಟ್ ಆಗುತ್ತೆ. ಮಾಡಬೇಕು ಇಲ್ಲಿ, ಇದು ಲೆಂತ್ ಗೆ ರಿಲೇಟ್ ಆಗುತ್ತೆ. So it is gases, liquids, so only solid, only gases and liquid. Only solids. Yes, option C, the right one. Kiran. Okay, only for the solids. Next question. Two wires have the same material and length. So material same ide, material same, Young's modulus same. Length kuda same anta ide, but their masses are in the ratio of 4:3. If they are stretched by the same force, their elongation will be, so their elongation ratio is in here. Elongation mass relation ಈ ಕ್ವಶನ್ ಅನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು, ಆಯ್ತಾ? So see here, that is it is based on the Young's modulus. So here masses ratio is 4:3. Forces are same, then the material is same, therefore the Young's modulus will be same. So Young's modulus is equal to, our formula is FL upon A into delta L. ಇಲ್ಲಿ ನೋಡಿ, F is equal to ನಾವು ಏನಿಂದ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬಹುದು, mg into L upon A into delta L. ನಾನು ಈಗಷ್ಟೇ ಹೇಳ್ಬೇಕಾದ್ರೆ ಹೇಳಿದ್ದೆ ನಿಮ್ಗೆ, ಹೌದಾ? ಸೊ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಗೆ ಮತ್ತೆ ಮಾಸ್ ಗೆ ಏನ್ ರಿಲೇಷನ್ ಆಯ್ತು? ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅಂತ ಆಯ್ತು ಇಲ್ಲಿ. ಬಟ್ ದೇ ಆರ್ ಗಿವಿಂಗ್ ಯು ಮಾಸ್ ಅಂಡ್ ದ ಎಲಾಂಗೇಶನ್ ರಿಲೇಷನ್, ಹೌದಾ? ಮಾಸ್ ಮತ್ತೆ ಎಲಾಂಗೇಶನ್ ರಿಲೇಷನ್ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಇಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ದ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್, ಹೌದಾ? ಸೊ ನಾವೇನ್ ಫರ್ದರ್ ಆಗಿ ಸೊಲ್ಯೂಷನ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಂತ ಇಲ್ಲ ಇಲ್ಲಿ. It is 3:4. Yes, Harshita. So it is 3:4, right? I hope you are understanding this mass and elongation, delta L relation. So ಈ ಫಾರ್ಮುಲಾ ದಿಂದ ಗೊತ್ತಾಗುತ್ತೆ ನಮ್ಗೆ, ಅದು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ. Therefore it is 3:4. We can prove it also. So if you require little, we will see, that is delta L1 upon delta L2 is equal to m1 upon m2, ಹೌದಾ? ಅದು ಮಾಸ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಸೇಮ್ ಇದೆ, ಜಿ ವ್ಯಾಲ್ಯೂ ಎಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ ರೇಷಿಯೋ ತೆಗೆದಾಗ, ಬಟ್ ವಿ ಆರ್ ಲೆಫ್ಟ್ ವಿತ್ A2 by A1, right? So here if you substitute, then it is 4/3, that is 3/4 ಅಂತ ಆಗತ್ತೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಏರಿಯಾದಲ್ಲಿ ನಾವ್ ಏನಂತ ಮಾಡ್ತೀವಿ, ನಾವ್ ಇದು ಏರಿಯಾದನ್ನ ಡೆನ್ಸಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಹೌದಾ? ಡೆನ್ಸಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್. Therefore here volume can be written as, ವಾಲ್ಯೂಮ್ ಅನ್ನ ಯಾವ ರೀತಿ ಬರಿಬಹುದು, ಏರಿಯಾ ಇಂಟು ಲೆಂತ್ ಅಂತ ಬರಿಬಹುದು, ರೈಟ್? ಸೊ ಏರಿಯಾ ಲೆಂತ್ ಅಂತ, our mass is proportional to area ಅಂತ ಆಗುತ್ತೆ. Mass is proportional to area ಅಂತ ಬರುತ್ತೆ based on this relation. So according to that, if you simply, it is 3:4. It is 3:4, right? Always from the first concept we can understand. That is more simple. Then the next question. A rubber cord of cross-sectional area 1 millimeter square and unstretched length 10 centimeter. Okay. Then next is stretched to 12 centimeter. So initial length 10 centimeter anta ಹೇಳ್ತಿದ್ದಾರೆ, then final length 12 centimeter anta ಹೇಳ್ತಿದ್ದಾರೆ. Then it is projected to a stone mass 5 gram. So mass is done. Then Young's modulus ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು 5 into 10⁸ ಅಂತ ತಗೊಳ್ಳಿ. Young's modulus is 5 into 10⁸. The tension in the rubber cord is so area is given, initial length is given, final length is given, mass is given, Young's modulus is given. Then we just require mg. Option C. Yes, it is 100. Yes, very good. So it is 100. Directly use again the Young's modulus formula and you can solve this. So what we are going to do here, that is given by y is equal to FL upon A into L2 minus L1. Change in length anna navili L2 minus L1 anta tagobodu. Hauda? So force is not given. So force kottilla. So namge tension andre en bekagatte, actually idu mg bekagatte. Namge ide bekagiddu term idi. Yes. So this is area into L2 minus L1. Young's modulus is given. Initial length 10 centimeter anta ide. Area 1 into 10⁻³ anta ide. L2 minus L1 will be 2 into 10⁻². So please simplify it yourself. We are getting option C, that is 100 Newton. So all the given data is there. Namge mg ne bekadadilli aita. That is tension anta keltidare, not force. Yes. Let us go for the next question. Out of the following material, whose elasticity is independent of temperature? Any idea? So out of the following, which is having the independent of temperature? Yes, it is inwards steel. Okay, so ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ actually ಇದು temperature, whatever the elasticity is there, both are inversely proportional. But here, whatever inward steel is there, it is not dependent on the temperature factor, but for other materials it is inversely proportional. Then the next question. So again it is theory. An iron bar of length L and cross A is pulled. So length L ide, area A ide, and it is by a force of F Newton from both ends so as to produce an elongation in meters. Which of the following statement is correct? So can you give the answer here? See, elongation is inversely proportional to length. Elongation is, yes, elongation is directly proportional to cross section. Elongation is inversely proportional to, yeah, elongation is directly proportional to Young's modulus. It is option C. It is option C. Yes, very good. Okay. And the next question, the ratio of the change dimension at right angles to applied force to its initial dimension is known as. So, longitudinal strain anta bantu. Poisson's ratio, lateral strain, shear strain anta bantu. So that is C. Yes. It is option here. Straight. Okay. Then the next question. Forces whose length and diameter respectively are given below are made up of the same material. Which of these will have the largest extension when same tension is applied? And same tension is applied. So see this. So same tension ಅಂದ್ರೆ F same ಇದೆ. 4 wires values they have given. ಅದು ಯಾವ್ದಾದ್ರು value length ಮತ್ತೆ diameter value is given. They are made up of the same material. Okay, which will have the largest extension. So let us see. So it is given by, okay, what is the answer? Okay. Yes. So see here, how we can solve this extension. You can calculate for all the values here. ಇಲ್ಲಿ ನೋಡಿ 1 meter 1 millimeter, option B ಅಲ್ಲಿ ಏನಿದೆ 1 millimeter 1 millimeter, ಇಲ್ಲಿ 2 meter 2 millimeter, 4 meter 4 millimeter, and option A is 0.5 meter and 0.5 millimeter, right? So if you simplify this one, how we can simplify this? We know that that is the elongation and the radius relation is, it is delta L is equal to L upon, only a formula I am taking, L upon D square, L upon D square here. Okay, so this is delta L is how much? It is 0.5. Delta L is 0.5. The next L value is equal to, this is 0.5, same length anta ide adu aita, whole square. So I'll write this once again. This is not clear. So here, that is delta or L by, it is L by D square is equal to, so L by D square, first one you calculate ಮಾಡಿ, 0.5 upon 0.5 millimeter ಅಲ್ಲಿ ಇದೆ, meter ಅಲ್ಲಿ ತಗೋಬೇಕಾಗುತ್ತೆ, it is 10 raised to minus 3, this is whole square is equal to, so if you simplify this, we are getting it as 2 into 10 raised to 6, 2 into 10 raised to 6. Then next one, similarly for next one, it is 1 into 10 raised to minus 3 divided by, it is 1 into 10 raised to minus 3. So if you simplify this, we are getting here 1. Similarly for C and D you calculate. So if you calculate for C and D, yes, A is the correct option. A is the correct option here. Aita? So same way calculate ಮಾಡಿ, 2 divided by 2 into 10 raised to minus 3, 4 divided by 4 into 10 raised to minus 3. So one option A ಅಲ್ಲಿ ನಮಗೆ 2 into 10 raised to 6 ಅಂತ ಬರುತ್ತೆ, option B ಅಲ್ಲಿ 1 ಬರುತ್ತೆ, option C ಅಲ್ಲಿ 1000 ಬರುತ್ತೆ, and option D ಅಲ್ಲಿ 1000 ಅನ್ನೇ ಬರುತ್ತೆ. ಆಯ್ತಾ? So compared to all the values, A is having the highest value here, right? So therefore option A is the right one. The formula is L upon D square. Let us go for the next question. So see, when the intermolecular distance increases due to tensile force, then, so there is no force between the molecules, there is a repulsive force between the molecules, there is an attractive force between the molecules, there is zero resultant force between the molecules. So ಏನide question ಏನide ನೋಡಿ, the intermolecular distance increases, ಅಂದ್ರೆ the force between the atoms or the molecules increase ಆಗ್ತಾ ಇದೆ. So ಯಾವ reason increase ಆಗುತ್ತೆ? A, B, C, D. Okay, yes, ಇಲ್ಲಿ attraction ಇದ್ರೆ ಹೆಚ್ಚಾಗತ್ತಲ್ಲ, intermolecular force ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗುತ್ತೆ. If you are saying there is an attraction force between the molecules, then intermolecular force will be increasing. Intermolecular distance ಹೆಚ್ಚಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಏನ್ ಹೇಳ್ರಿ, repulsive force ಹೆಚ್ಚಿದೆ ಅಂತ. So as the intermolecular distance is increasing, means the molecules are experiencing the repulsive force. The molecules are experiencing the repulsive force. Yes. So this is actually first question repeat agide. So here you can solve this. The next question. one end of a steel wire of area of cross section 3 millimeter square is attached to the ceiling of an elevator moving up with an acceleration of 2.2 into 2.2 meter per second square. If a load of 8 kg is attached at its free end, then the stress developed is. So already you know the formula, stress developed. Stress is equal to there. Yes. Try madi, nive try madi. Stress is equal to force by area anta barutte. So force. Acceleration is given 2.2. Mass is given as 8. Area is given as 3 into 10 raised to minus 6. 3 into 10 raised to minus 6 barutte aita. So let us see what is your answer. Ellaru onond answer heltidira. C, D, B. Which one is correct? Other students? It is C. It is C. 20 into 10 raised to 6. Okay. So why you are getting it as option C? See here. Here one thing you need to understand, that is the elevator is moving in the upward direction. Illi laws of motion ad one concept and now use ಮಾಡ್ತಾ ಇದೀವಿ. That is the tension T is equal to mg. It is moving upward direction means it will be minus of ma. It is minus of ma. So m is common here, that m is your 8, and acceleration due to gravity, for convenience I'll consider it as 10 instead of 9.8, minus acceleration is 2.2. So if you simplify this, see how much you are getting. 10 minus 2.2 into 8. So calculate this one. Then next use stress is equal to formula. So here stress is equal to, we are getting it as 62.4 divided by area is 3 into 10 raised to minus 6. So simplify this, you will get the answer. So lane trick ide antandre idu elevator moving in the upward direction ide. Therefore directly we cannot take it as mg. We need to take it as what? That is mg minus ma. We need to take it as mg minus ma. Yes, let us go for the next question. So see this question. The magnitude of the force developed by rising the temperature from 0 degree Celsius to 100 degree Celsius. And the initial temperature is 0 degree antide, final temperature is 100 degree Celsius of the iron bar of 1 meter long and 1 centimeter square cross sectional area. Area is given, then its length is given, and this is alpha value. Okay, this is alpha value here. That is 10 to the power of minus 5. It is 10 to the power of minus 5. This one. Here it is. Alpha is equal to 10 to the power of minus 5. And Young's modulus is given as 10 to the power of 11. It is 10 to the power of 11. Right? So here what they are asking you to calculate the magnitude of the force. It is solve thermal properties to force, thermal stress. Our formula na we use madbekagutte. That is F is equal to YA alpha delta T. So idu formula ide, calculate ಮಾಡಿ. Y ಕೊಟ್ಟಿದ್ದಾರೆ 10 raised to 11 ಅಂತ. Area is given, it is 1 centimeter square. Alpha is given 10 raised to minus 5. Delta T, that is change in the temperature, is also given. So option 10 raised to 4 or 10 raised to 3. Check the power once again. Yes. It is 10 raised to 3 Newton. Option A is correct. So number 10 raised to 11 into 10 raised to minus 4 into 10 raised to minus 6 into 10 raised to 2 anta agutte. Values alli ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ? y ವ್ಯಾಲ್ಯೂ 10⁻11 ಅಂತ ಆಯ್ತು, 10⁻⁻4 ಅಂತ ಆಗತ್ತೆ, 10⁻⁻6 ಆಯ್ತು, then 10⁻2. So if you simplify everything, we will get it as 10⁻3, right? Let us go for the next question. The upper end of wire 1 meter long and 2 millimeter radius is clamped. The lower end is twisted through an angle of 45 degree. The angle of shear is, so this is based on the shear stress concept. So illi ಒಂದು shortcut formula na use ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So the formula is given as angle of shear. Take down this formula, that is angle of shear is equal to, so the angle of shear is given by theta divided by delta x. Theta ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ? 45 degree ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, ಹೌದಾ? Delta x, so delta x is nothing but what? That is, here we will consider it as r theta upon L. So substitute the value here, that is nothing but 2 into 10⁻³ into theta is 45 divided by L is 1. So 45 into 2 is nothing but what? 90, ಹೌದಾ? Into 10⁻³ ಇದೆ, ಯಾವ್ದು ಬರುತ್ತೆ? ಆಪ್ಷನ್ A, B, C, D. Option A it is option A. Yes, okay, so take down option A. I hope the solution is clear to you. So 2 more questions we will see. Yes, the radii of 2 wires of same material are in the ratio. If the wires are stretched by equal forces, the stress produced in them will be. So ಈಗ already ಈ ತರ questions ಅನ್ನ ನಾವು ಮಾಡಿದೀವಿ. ನೀವು ಇಲ್ಲಿ radius ratio is 2/1 or 2:1. Okay. So what about your stress? Stress and radius are inversely proportional. According to the formula, they are inversely proportional. Yes, it is 1:2. Yes, very good. It is 1:2. Then the next question. So this one already we have solved this. This is also covered. Okay, this one. That is, if the length of a wire is reduced to half, then it can hold the same load, 1/4 load, half load, double load. So length ಮತ್ತೆ force relation. Length ಅನ್ನ ನೀವು reduce ಮಾಡ್ತಾ ಇದ್ದೀರಾ half ಆಗಿ. So what happens to the load? What you can say? Same 1/4. See, according to stress is equal to, formula is force by area. ಹೌದಾ? ಸೊ ನಮ್ಗೆ ಎಲ್ಲೂ ಲೆಂತ್ ರಿಲೇಷನ್ ಮತ್ತೆ ಫೋರ್ಸ್ ರಿಲೇಷನ್ ಎಲ್ಲೂ ನಮಗ್ ಕಂಡು ಬರಲ್ಲ. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಲೆಂತ್ ಎಷ್ಟೇ ರೆಡ್ಯೂಸ್ ಆಗಲಿ, ಡಬಲ್ ಆಗಲಿ, ಏನೇ ಆಗಲಿ, ವಾಟ್ ಎವರ್ ದ ಲೋಡ್ is holding, it will not change as it's independent of the length. Therefore, option A is correct here. Option A is correct here. That is, same load it will catch hold, right? Because force and length, there is no relation. It depends only on the force and area, and that too area of cross section, right? Therefore, it will not come there. It is same load. Last question for today's class. The substance which shows no elastic after effect practically is. The substance which shows no elastic effect. Steel, rubber, copper, cords. Yes. Which one? It is D, cords. Yes, it is D. Cords will not show the elastic limit. No elastic effect we can see practically on the cords. Option D is the right one here. Okay, students. So we will continue in the next class. I hope it is clear to you. Thank you, everyone. Have a good day.